Hello there. Today, we are going to be learning about vectors. Vectors are basically numbers with directions to get precise movement. Let's start with a simple introduction to the coordinate system. The coordinate system is made up of the x and y axes, showing horizontal and vertical movement. The y-axis shows vertical movement, and the x-axis shows horizontal movement. Say I put a point here. To represent this point, we use something called an ordered pair, representing the x and y values. So this point would be 3 and 4. The coordinate system or plane is divided to 4 quadrants. Any point on the first quadrant is always 2 positive numbers in the ordered pair. Any point on the second is a negative number followed by a positive number. Any point on the third is both negative numbers. And any point on the fourth is positive, then negative numbers. Great! Now let's move on to vectors. As we know, vectors are numbers with directions. So let's work with our previous point, 3 and 4. Another way to represent this point is using unit vectors I hat and j hat, representing horizontal and vertical movement, as they also correspond to x and y. Vectors are also represented with letters with an arrow on top of them. So this vector v is represented like this, 3i hat plus 4j hat. Say we have an arrow connecting point A and B, where A is at its tail and B at its head. To represent this line or arrow, we use this vector AB with an arrow on top. Now let's move on to basic operations on vectors. Say we want to add 2 vectors like these, whereas A is 3i hat and 4j hat, and B is 2i hat and 3j hat. We start by adding the 2i hat values, 3 and 2, and then the 2j hat values, 4 and 3. This shows transformation and movement from point A to B. Now let's learn about scaling vectors. Suppose I have the same vector from earlier. If we double it, it should look something like this. Bigger numbers means stretching the vector, and smaller numbers mean shrinking the vectors. Now imagine a point here. If we want to get there, we don't have to move 3 steps to the right and 4 steps up. This is because we have something called a magnitude. To calculate the magnitude of vectors, we use the distance formula. By applying these numbers here, we get 5. Also, magnitudes of vectors are represented like this. Note that these lines do not represent the absolute value. Dot products. These help you know how much 2 vectors point in the same direction, or compare between the 2 directions of 2 vectors. To get the dot product of 2 vectors, we multiply the 2i hat values and add them to the product of the j hat values. Dot products also have many properties, like commutativity, which means when multiplying 2 vectors together, you can switch them, just like normal multiplication. There is also perpendicular vectors, which means that any 2 vectors that form a right angle always have the dot product of 0. I hope this video helped explain basic introduction to 2D vectors. Make sure to like and subscribe for more.